what were the measurements from 50 years ago? Are they trusted? Are they just low resolution? Like, what kind of a picture do they paint now? What are you expecting?
Yeah, well, some of the measurements are, we're also doing, and for example, the measurements that we're taking of like the temperature and pressure, we're doing that over a different part of the planet. So we're going to be able to compare it to those past measurements. But yes, like we do trust all of that data that was taken before. We just want to compare what we're seeing now to what we're seeing, what we saw then. And then that's also the case for the mass spectrometry measurements. We're taking some of, basically the same type of instrument, but that has been updated. So we're able to get much better precision and much finer details now than we were able to 40 years ago.
Oh, by the way, you mentioned the term fugacity. I haven't heard that since college, so it jumped out at me. I did chemical engineering, bachelor's. So.
Yeah.
Okay. What is this data going to tell you? Like, what do you imagine that you're going to learn about Venus from the data, and what would be the consequence of it? Like, what's one example, small thing?
Sure. So one thing that we're really interested in is the isotopes. So the reason for this is that by by actually measuring these isotopes, we're going to be able to put Venus in context with the rest of the solar system. So we've been able to take these measurements at a variety of different terrestrial bodies or even small bodies within our own solar system. I'm talking Earth, Mars, even like some asteroids and comets. But we haven't been able to take all of these the same isotopic measurements at Venus. And so by one of those, for example, is xenon. We just haven't been able to take that at Venus yet. So by looking at these measurements and how they differ across from each other or how they stay, how they're similar, we're able to make theories and understand better about the formation mechanisms of our entire, our solar system, at least of rocky bodies. So that's one example that we're looking to understand more about.
Before we continue, I've been personally funding the Finding Genius podcast for 4.5 years now, which has led to 2,700 plus interviews of clinicians, researchers, scientists, CEOs, and other amazing people who are working to advance science and improve our lives and our world. Even though this podcast gets 100,000 plus downloads a month, we need your help to reach hundreds of thousands more worldwide. Please visit findinggeniuspodcast.com and click on Support Us. We have 3 levels of membership from $10 to $49 a month, including perks such as the ability to see ahead in our interview calendar and ask questions of upcoming guests, transcripts of podcasts you're interested in, the ability to request specific topics or guests, and more. Visit findinggeniuspodcast.com and click Support Us today. Now back to the show.
Okay, well, when is this mission planned to happen? How soon?
So we are working towards a launch in the 2030, 2031 timeframe, which, feels like a long time, but when there's so much work to be done, the time is just going to fly by.
Okay, so other missions that you're a part of that you think you're going to be really significant in terms of the knowledge they bring back?
Other missions that I'm part of?
Yeah, other, beyond the Venus mission, are there other ones that you're part of that you think you're going to bring back some really interesting data that we could talk about, or we can go deeper on the Venus ones?
So the only mission that I am a part of is the Vinci. However, one thing that I also spend a lot of my time doing is learning about exoplanets. And so some other interesting missions are, of course, JWST. And then as we prepare for the Habitable Worlds Observatory, this is like the perfect crossover for me because Venus, we kind of call it like the exoplanet in our own backyard because historically our observational bias has been to observe these really large, gaseous, hot exoplanets. But with JWST and many of the observational platforms and for the future, we're going to be able to start observing more rocky planets and also like rocky planets that have very appreciable atmospheres. So by studying more about Venus, we're going to be able to extrapolate that information out to all these other exoplanetary systems, looking at these other rocky exoplanets and learning more about them and, why they are the way they are, and also learn a bit more about, possibilities for habitability just by studying, our exoplanet next door.